Alright, in this video we're going to cover how to more simply run a task and then pull information out of it. The first thing we're going to need is both a actor in which we will run the task and then pull out information, as well as an actual task to do the calculations. That's done by just right-clicking, selecting a blueprint class, then grabbing an actor, which I've named here as tutorial actor, and searching up short async task, which I have named mine to be tutorial task. Within the tutorial actor, we need to go ahead and pull off of the event begin play. From there, we are going to immediately create a thread pool. This is going to be where the tasks are run on. Without this, it can't run and things will break. So we're creating a dedicated thread pool right now, something of thread number to be like 3, and then you can name it. I've named mine task thread pool. Immediately doing a check to make sure that it has been created, and then we will actually create an async task. This needs to be set to the class being the task you've just made. Mine's name is tutorial task, as I previously mentioned. And then from there, we need to pull off of the return value, promote that to a variable to stop any back-end memory garbage collection from destroying some of the information related to our task. Finally, we need to run the task. This node will actually run whatever is going to happen within the task on the separate thread. And a convenient add-in, a convenient part of this is the callback node. Now, because it's a stateful async task, we can more simply pull information out of it once it's been run, and that's going to be done with the callback. So once this is completely run through, once our tutorial task is completely finished running through, it will then fire this callback, which all this is a create event. It's just done by typing create event, selecting the dropdown, creating a matching function. I have named mine to be post async over here by just renaming it. And we'll go into that in a second. First thing we're going to do is open up the tutorial task. Sorry, whatever your task may be named. And we can see here, yours would be completely empty. All you need to do is come up to graphs, select override, and then select execute and initialization. Initialization is just as it sounds. It just is going to be run. It literally says right here, it's called before execute. It's just going to be used for setting basic variables and whatever types of information we may need to run, whatever we may need. There maybe, as an example, you just need a simple variable, a simple integer to be set at a random number. You could be here, instead of just random number. Every time the task would be run, maybe we would need a random number. And that could be done right here. So it would set our random number from whatever random integer stream we've created, and that would be unique to this task every time it would be run, and that would be done within the initialization logic. We can see here I have done a little bit of things within the execute. One of them being I've set the thread to get the current thread name. Conveniently enough, we know what it will be. It'll be task thread pool. There will be a little bit more information, as we'll see, but we're going to append that into the thread variable. So that will just add on whatever the thread's name is to this. So it'll say current thread and then its name. Secondly, I have an integer just doing a basic addition. So it will count itself up from 1 all the way to 100. And we're going to pull out both of these variables so we can see that they've actually been changed. And there has been calculations that have gone on. Now within my post async function, which was just that callback, so whatever your callback function is named, we're going to be working in there now. You'll see that there would just be the function's execute node, and it will have a task reference. Now, this is going to be the now completed task. Once this is running, this callback is running, we know the task is finished, so this is going to be that finished task. We'll want to make sure that it's valid. There can be occasions in which a non-valid task is ran through, so we want to do a validity check first, and then we're going to cast back to the tutorial task, which will allow us to then pull out information. We see here that pulling from the as tutorial task, we can do get, and we'll see the two variables that I created, both the counter and the thread. And I have set both of those up to print, and I have dropped the tutorial actor into my game environment so it can actually run on event begin play. We'll play, and we can see up here at the top that the counter is now at 100, and the current thread is named to task thread pool number 2. So we know that the task is actually run, because in no point within this actor did we interact with the counter other than just printing it. That was all done within here, where the counter was added on 100 times. I hope that makes more sense. This is, as I've mentioned, just going to be used for computations and calculations. You can't spawn in any objects or any other actors. So whatever types of math you can offload onto other threads, this is a perfect way to do that. If you have any questions, please feel free to ask as always.